Hello guys, welcome you all to my YouTube channel. So here we will be discussing different concepts related to mathematics. And we are into the discussions of JEE from previous past few sessions, and we also finished certain problems and concepts related to JEE. We have covered certain concepts and also we have solved certain problems related to JEE. So without wasting time, let's start today's session with some different types of problems. Right? So what is given here? Matrix A has m rows and n plus 5 columns. Matrix A has m rows and n plus 5 columns, and matrix B has m rows and 11 minus n columns. If both AB and BA exist, then what are the possibilities? AB and BA are square matrices. AB and BA are the matrices of order 8 into 8, 8 cross 8 and 13 cross 13. AB is equal to BA or none of this. So this is a simpler problem compared to previous things. Right, in previous we have solved many problems related to trace, right? So this is simple. Let's start today's session with a simple problem, then we can move ahead. Okay, so what is the condition if AB and BA both exist? Okay, if AB and BA both are existing, both exist. Okay, so if AB exists, what is the condition? Number of columns of A should be equal to number of rows of B. Right? So that is the condition. If A into B is possible, number of columns of A should be equal to number of rows of B. Okay. So what is the number of columns of A? A is having n plus 5 columns. N plus 5 should be equal to number of rows of B, and B is having how many rows? M rows. Okay, mark it as equation 1. Now, if BA exists, AB exists, this was the condition. If BA exists, number of columns of B should be equal to number of rows of A. Number of columns of B is what? 11 minus n. 11 minus n should be equal to number of, BA is existing, number of columns of B should be equal to number of rows of A. Number of columns of B is 11 minus n, and number of rows of A is how much? Number of rows of A is m. Right? So number of columns of B is how much? 11 minus n, and number of columns of A is m. So now adding both, 1 plus 2. So plus n and minus n cancels. So 11 plus 5, that will be 16, is equal to 2m. So I can write m as equal to 8. Right? M is equal to 8. Then from equation 2, what is that? 11 minus n is equal to 8. N is equal to 3. Okay. So m is equal to 8 and n equals 3. When m is 8 and n equals 3, what is order of A? Number of rows cross number of columns. Number of rows is m cross number of columns n plus 5, that is 8 cross 8. M is 8, n is 3, 3 plus 5 is 8. Similarly, order of B is how much? Matrix B is rows m cross 11 minus n, that is m is 8 cross n is what? N is 3. 11 minus 3 is 8. So order of A is 8 cross 8, order of B is 8 cross 8. Right? So AB and BA are square matrices. 8 cross 8 means it is a square matrix. Right? Then See, if order of A is 8 cross 8, order of B is 8 cross 8, what will be order of A into B? That also will be 8 cross 8, right? Order of AB is how much? See, number of columns into number of rows. N plus 5 into M. That is nothing but N plus 5 is how much? 8. 8 cross 8. Order of BA. Order of BA. Right? That is number of columns of B into number of rows of A. Number of columns of B is 11 minus N into number of rows of A, M. So that's 8 cross 8. So order of AB is 8 cross 8, that is a square matrix. Order of BA is 8 cross 8, that is a square matrix. Right? So AB is 8 cross 8, BA is also 8 cross 8. So AB and BA are square matrices. Right? Coming to this one, see, AB and BA are of order 8 cross 8 and 13 cross 13. That is not true. Okay? AB is equal to BA, that is not possible. Right? So only it is possible when it is having identity matrix. So, but that is not possible here. And none of this will not be our answer, as option A is satisfied. Okay? So option A is our required answer. Okay? So make a note of this. So friends, I hope you have understood that previous problem. So let's proceed to the next one. Okay? So what is given here? Let A is equal to 0 alpha alpha and 0 alpha 0 0 and A plus I to the power 50 minus 50A is equal to A B C D. A to the power A plus I to the power 50 minus 50A is given as what? A B C D. Then the value of A plus B plus C plus D is. Okay? So this is the question which is asked here. Okay, so out of this, any one option will be there. If we want to find this, first we should know the value of A, B, C and D individually. Then we can directly calculate this. Okay, so now A is what? 0, alpha, 0, 0. What will be A square? 0, alpha, 0, 0. Into 0 alpha 0 0, right? So this will be 0 into 0, 0 into 0 0, alpha into 0 is 0, 0 plus 0 is 0. Now 0 into alpha is 0 plus alpha into 0 is 0, so 0 plus 0 will be 0, right? 0 into 0 plus 0 into 0 0, 0 into alpha plus 0 into 0 0, right? So I can write A square as equal to 0. It is a 0 matrix, null matrix. A square is equal to 0. Okay. Similarly, if to this 0 matrix, if I multiply any matrix, right, that is going to be 0. Right. So as this A square is 0, A square multiplied by anything is also 0. Like if I want A cube can be written as A into A square. As A square is 0, A into A square also will become 0. So A cube is also equal to 0. A to the power 4, A to the power 5, anything you take, it will be 0. Therefore, I can write A to the power k as equal to 0 for every k greater than equal to 2. For every k greater than equal to 2. When k is 2, we have seen it becomes A square, that is 0. A cube 0, A to the power 4 0, everything of henceforth will become 0. So for every k will be equal to 0. For every k is greater than equal to 2. So we got the value of A to the power k, right? So now what we need? A plus I to the power 50 minus 50A is given in this way. Okay. So now tell me, what is A plus I the whole square? So if I want to calculate A plus I the whole square, it will be what? A square plus I square plus 2AI. A square plus I square plus 2AI. A square is 0. We know that I square is nothing but 1. I is 1. I square will be 1. So this can be written as, this is I plus 2A. Similarly, A plus I to the power 3 right? So it is nothing but a plus I into a square, a plus I the whole square, right? So this will be a plus I is how much? So keep it as a plus I itself, a square plus I square, or a plus I the whole square. We know what is a plus I the whole square? I plus 2a. So this, if I calculate ai plus 2a square plus I square plus 2ai, right? A square is 0, this becomes 0. I square is 1, so I can write I square as nothing but I only, right? I plus 3ai. So what is this? A plus I the whole cube. So now similarly, if I want a plus I to the power of 4, so I can write it as a plus I into a plus I cube. So this is a plus I into I plus 3ai. So once again, this will be ai plus 3a square I, 3ai or 3a I can write in generally, right? So 3a square, a into I, ai plus a into a, 3a square plus I square plus 3ai. So this is nothing but 3a square is 0, I square is I, right? 3ai plus ai, 4ai, that can be written as 4 times of a plus I to the power 4. See here, you can see when it was only a plus I, it was, or a plus I can be written as I plus a also. A plus I the whole square is I plus 2a. When it is square, we get I plus 2a. When it is cube, we get I plus 3a. You can see here, when it is square, here we are having 2a. When it is cube, here we are having 3a. When it is to the power 4, here we are having 4a. So similarly, I can write a plus I to the power 50 is equal to I plus 50a. So that is equal to what? I plus 50a. Okay. So a plus I to the power 50 is what? I plus 50a. So I can shift this, a plus I to the power 50 minus 50a as equal to I. A to the power, a plus I to the power 50 minus 50a as equal to I. But what is our given condition? A plus I to the power 50 minus 50a is equal to a, b, c, d. But here it is equal to I. So therefore I can write a, b, c, d. This is what? This is a, b, c, d as equal to I is what? 1, 0, 0, 1. So comparing both things, we get what? A is equal to 1, B is equal to 0, C is equal to 1, D is equal to, sorry, C is equal to 0, D is equal to 1. Right? So we got A is 1, B is 0, C is 0 and D is equal to 1. What is asked for us? A plus B plus C plus D. A plus B plus C plus D is equal to A is 1, B is 0, C is 0 and D is 1. That will be 2. Right? So the option is option A. Okay? So this is how we need to do it. Right? So now pause the video and have a look at this. Okay friends, let's proceed with the next problem. So what is the problem given over here? The product of matrices. A is a 2 cross 2 matrix which is a function of theta. Which is a function of theta. And so this is cos A. Just a minute. No, this is only B, not sin B, only B. Okay. So what is given over here? The product of the matrices A is equal to some 2 cross 2 matrix, right? So 2 cross 2 matrix. So it is a function of theta, and here matrix B is a function of phi. They are saying that the product of these two matrices will be a null matrix if theta minus phi is equal to. Will be a null matrix if theta minus phi is equal to. So how to proceed with that? Check with the product A into B. Right. So what else they have given? Nothing. Right. That's it. So solution A into B can be written as cos square theta cos theta sin theta. Here cos theta sin theta and sin square theta into what is B? Cos square phi cos phi sin phi. Then here cos phi sin phi, then sin square theta. Okay. So this, what will be the product of this? Cos square theta into cos square phi. It will be cos square theta into cos square phi plus cos theta sin theta into cos phi sin phi. Cos theta sin theta into cos phi sin phi. Right. So what will be second one? Cos square theta into cos phi sin phi, right, plus this into this I can write sin square, this is phi, sin square phi into cos theta sin theta. Okay. So the second part. So what will be second row? Cos theta sin theta into cos square phi, right, cos theta sin theta into cos square phi, and here plus cos phi sin phi into sin square theta. So next one, this into this, I will get cos theta into sin theta into cos phi into sin phi plus sin square theta into sin square phi, theta into sin square phi. Okay, that is what it is there. Right. So there is nothing but just multiplication, applying the rules of matrices. So now here I am having cos theta. This is phi. Okay. So cos square theta I am having, cos square phi I am having. Here I am having, here cos theta is there, here also cos theta is there. Right. Here cos phi is there, here also cos phi is there. So what I can take? I can take cos theta into cos phi as common. If I take cos theta into cos phi as common, so what will remain inside? Cos theta cos phi plus here sin theta sin phi. Okay, and coming to here, here I am having cos square theta, here I am having cos theta. So I can take cos theta out, and what else I can take? Here I am having sin phi, here I am having sin square phi. I can take sin phi outside, right? So what will I get? Cos square theta is taken out. So here cos theta into cos phi. So cos theta into cos phi right? But cos theta and sin theta are here. So one cos theta is outside, one cos theta will be inside, right? So cos phi as it is, sin phi has gone, so it will not be there. Here one sin phi is outside. Here we are having sin square phi. Out of sin square phi, one sin phi is outside. So one sin phi will be inside. And here, what else I am having? Cos theta also I am having outside. So this cos theta will not come. Only sin theta will come. Sin theta. Okay. Coming to this, here I am having cos theta. Right? But am I having cos theta here? No. Leave it. Here I am having sin theta. So here definitely I am having sin theta. So take sin theta out. Now cos square phi I am having. Cos phi I am having. I can take cos phi also outside. Cos phi. So what remains? Sin theta is gone. Right. So cos theta as it is. Sin theta is not there. But cos square phi. Cos phi is outside. One more cos phi will be inside. Right. Plus cos phi is gone. Leave it. Sin theta is gone. So sin phi will come. Sin phi into sin theta. Okay. And here I am having cos theta. So do I have cos theta? No. Right. But sin square theta and sin square phi. Do I am having sin theta and sin phi here? Definitely. So take sin theta into sin phi. If I take sin theta into sin phi, inside will be cos theta into cos phi plus sin theta into sin phi. Right, this is how it will be there. Okay. So now what is cos A cos B plus sin A sin B? It is cos of A minus B. Everywhere I am having this thing, right? Cos theta cos phi sin theta sin phi. Here also cos theta cos phi plus sin theta sin phi. Cos theta cos phi plus sin theta sin phi. Cos theta cos phi plus sin theta sin phi. So this entire thing can come outside. This entire thing can come outside. Initially you take it outside. Cos theta cos phi plus sin theta sin phi. So if I take outside, what will be remaining in the matrix? Cos theta into cos phi, and there cos theta into sin phi, and here sin theta into cos phi, and there sin theta into sin phi. Right. So now what is that? This should be a null matrix. A into B should be a null matrix. 0 equal to 0. So now this entire thing becomes 0 either when this part is 0 or this part is 0. Right. So if I equate this to 0, what is this cos A cos B plus sin A sin B? That is nothing but cos of A minus B. Right. Cos theta minus phi. Right. I can write cos of theta minus phi as equal to 0. This if I equate it to 0, entire thing will become 0. Right. Cos theta cos phi plus sin theta sin phi is what? Cos of theta minus phi. So this if I equate to 0, there is nothing but cos of theta minus phi will be equated to 0. Right. So when cos of theta minus phi is equal to 0, then what will be the value of theta minus phi? Theta minus phi will be equal to what? It will be 2n plus 1 to pi by 2 for every n belonging to z. Right. So 2n plus 1 into pi by 2 for every n belonging to z. This will be our required value. This is the standard thing. When cos of theta minus phi is equal to 0 and cos theta is equal to 0, cos of some angle is equal to 0, the value of that angle will be 2n plus 1 into pi by 2 for every n belonging to z. This is the standard consideration. Right. So now whenever we got the value, so which is the right answer out of this? option C. So I hope this thing is clear. This simple simplification here, right? So this type of problems, many things you have come across, right? So this might not be that difficult for you people to understand. So have a close look at it and make a notes if it is possible. So guys, I hope you have understood the problems. So these were the three different types of problems for today's session. So keep signed in with the channel, right? So we'll be discussing different concepts. So we can stop the video for today here itself, and in the upcoming videos we'll take some more examples, some more problems which are very important for your JEE point of view. Okay. So for this we'll stop video here. So take care. Goodbye.